All right, well, welcome back. What we have here is, this is video 3 on how to solve, or simplify, I should say, simplify trigonometric expressions. All right, now there's many different ways of doing it, and as we stated before, a lot of times when you're looking at these, all right, is you want to try to figure out, is this going to be, where is the fundamental trig identities that we can use, okay? Different strategies we have this. So one of the key strategies, and we have example number 5, that's a 5, by the way, it's not a 3. I'm a horrible writer. I apologize for all those that are looking at me on YouTube and saying, wow, this guy is horrible. But, well, okay. Hopefully you find something useful out of this. But in any case, what we have is we have sine squared cosecant squared of x minus sine squared of x. Now, when you have this right here, there's a bunch of different ways of doing this. What we could do first is we could take this value and we could maybe see, okay, is there any way we're simplifying this? One way I look at it is that I see sine squared in both of these, but I also see a cosecant. So we could do two different ways of doing it. One thing is we could factor out sine squared of both this, and there's a bunch of ways of getting the same answer. And so if you see this right away, some of you might want to just take away and factor out the sine. Use a little algebra. I always like saying algebra, all right, to my students. Always remember algebra. All right, so you might see this right away and you say, okay, I'm going to take, all right, sine squared of x. I'm going to factor that puppy out. And what then I have left over is cosecant squared of x minus 1. All right? So we're just taking out sine out of both of these. Using an algebra, what we have left over is cosecant squared of x minus 1. Now, cosecant squared of x minus 1, recall, this is one of our trig identities because what we have is our fundamentals are sine squared of x plus cosine squared of x equals 1. We have, all right, if we divide by cosine, we have tangent squared of x plus, all right, 1 equals secant squared of x. That's another fundamental trig identity. If we divide by, and if you don't know this, I'm dividing by each one of these, and that's how I can help remember these. If you divide by sine, I'll have 1 plus cosine divided by sine is cotangent squared of x, and I'll have cosecant squared of x, and we have that right there. Now, from here, you can see that we have cosecant minus 1. Well, cotangent squared of x equals cosecant squared of x minus 1. If I just subtract that one to the other side. Oh, okay, so from these, all right, basic fundamental trig identities, I can create some other fundamental trig identities, all right, by just rearranging the equation. That's why, as I said before, algebra is king, all right? Algebra is king. I should do a little crown right here. Algebra is king, all right? There's his crown. All right, algebra is king. That's weird. All right, but we're going to take now is we're going to use this, and we're going to put in cotangent, all right? So I'm going to replace this expression with cotangent because that's the identity, all right? So cotangent squared of x, and that's going to be multiplied by sine squared of x. Now, from here, we are now going to simplify cotangent into sine and cosine. That's what we know. So cotangent, sine, and cosine. So we have cosine squared of x over sine squared of x times sine squared of x. These cancel out, and we're left with, guess what? Yes, cosine squared of x. That's a simplified version right there, and that's what we want. Now, some of you might be wondering, saying, well, I see this part, because there's another way of doing this. Maybe this is a little bit easier. Sine squared and cosecant, well, sine squared of x times, well, cosecant is actually 1 over cosecant squared of x. Oops, sorry, cosecant. Sine squared, I apologize. The same thing as sine squared of x. All right, so those are the same. And then we can say that minus sine squared of x. And what happens is these cancel out and turn into 1. Now we have 1 minus sine squared of x. 1 minus sine squared, well, once again, comes from one of these fundamental trig identities because cosine squared of x equals 1 minus sine squared of x, right? So I can just substitute this for cosine because that's what they're equal. And once again, I prove that, yes, this expression can be simplified, all right, into cosine squared of x. 2 different ways of doing the same problem. That is awesome. That's pretty sweet. All right, so that's that one. So either way is correct. Either way is good. All right, different ways of approaching the same thing. All right, this one might be a little bit faster. All right, but if you get used to seeing this just kind of sticks out. You can still get the same way, just have to do maybe a little bit more work, a little more trick. All right, next one. Secant cubed minus secant squared minus secant plus 1. Now, this right here, when you see something like this, is an example of a grouping problem. Okay, when you had in algebra. Well, remember, algebra is king. All right, and when you have this right here, if you can think of this, if we take secant and we just made it like y, y cubed minus y squared minus y plus 1. Now, if you were to simplify this, one thing we can do to simplify this is whenever you have a cubic with 4 terms, all right, is that we can take and group these values together. Okay, and what I'm going to do is I'm going to factor out a y squared out of here. Maybe you remember doing this back in the day. Y squared. When I do that, okay, when I factor out this y squared, all right, what I'll have then is going to be y minus 1 left over. So we have y squared, y minus 1. Well, now I'm going to take this value, and I want to see if I can make these two terms into y minus 1. So right here, I'm going to factor out a negative 1. And when I factor out negative 1, I'll have y minus 1. Okay, change this up real quick. Oh, all right. Well, let me move around. There we go. Okay, so I'm doing this. There we go. Oh, I can't do it. All right, sorry. My computer's getting a little bit crazy here. All right. Well, in any case, I can then factor out this value. So what I have is y squared, or y minus 1, times, all right, y squared, all right, minus 1, and I have my expression. Okay, I have my expression. So we're going to do the same thing over here, all right, and I'm going to take this, I'm going to factor out, instead of y, I'm going to factor out secant. So I'm going to factor out secant. So when I factor out secant, all right, I'm going to factor out actually a secant squared. All right, secant squared of x. And when I factor out a secant squared of x, what I'm left over is a secant of x minus 1. All right, and over here, I need a secant of x minus 1, so I'm going to actually factor out a negative 1. All right, what I have then is secant of x minus 1 again. And now from here, I can factor out my secant of x minus 1. And what I have left over then is going to be secant squared of x minus 1. Well, secant squared of x minus 1 is, if you recall, appears to be one of our fundamental trig identities. So right here, I'm going to take secant squared of x, all right, plus 1, all right, this plus 1 straight to the other side, and that's going to equal tangent. So I'm going to have secant squared of x minus 1, and that equals tangent. So I'm going to replace that with tangent right here. So I'm going to go tangent, that's going to be a tangent squared of x, and that's going to be multiplied by secant of x minus 1. All right. Uh-oh. All right. So that would be, I believe, our simplified answer, and that's what we got right here, and that's where we're going to go. All right. Well, hopefully this makes sense. Sorry that my thing got a little screwed up, but what we did was, once again, use our fundamental trig identities, all right, to simplify these expressions. We used some algebra. Remember, algebra is king. All right, right here. Algebra is king right here. And we get simplified to secant of x minus 1 tangent squared, all right, of x. All right. Yeah. So I hope this helps you out. Good luck and God bless in the rest of your problems. And yeah, I'll hopefully have my computer working a little better, and we'll have our final video, all right, on 2 more examples.